All right, tonight what we're going to be talking about are acid-base calculations. There are six different formulas that you are going to need to know how to manipulate. If I am going to find my pH, okay, remember I talked about in the previous video that there's a conversion between your molarity or your concentration of your hydronium ions and your pH, and this is the formula that you're going to use. In order to solve for pH, okay, so these are always what you're solving for, or what you can solve for. You're going to take the negative, so the negative, not the minus sign, but the negative. Find the log button on your calculator and then type in the molarity. All you have to do is type negative log and then type in the molarity and press enter and you'll get your pH, okay? In order to find your H plus concentration, you're going to need to take 10 to the negative pH. This is an exponent, so you're going to have to use that caret button and then negative pH. Your pOH is the exact same thing, except for instead of hydronium ions, you're trying to find that hydroxide ion. So to find your pOH, it is the negative log of your OH minus concentration. To find your OH minus concentration, once again, this is the molarity of your hydroxide ions, you would take 10 to the negative pOH. What's cool about your pH and pOH is that added together, they always equal 14. So a lot of times these two will be your in-between ones. So if I know pH, to find pOH, I'm going to use this guy. So I would just take 14 minus my pH to get my pOH. This is also another one that we're going to be using for strong acids and strong bases, which is all the calculations that we're going to be doing in this class. And the hydroxide ion and the hydronium ion multiplied together equals 1 times 10 to the negative 14th. So a lot of times in order to solve for it, you're going to take 1 times 10 to the negative 14th. Let's say I wanted to find my hydroxide ion concentration. I'm going to divide it by my hydronium ion concentration, and then it'll give me my hydroxide. All right, so let's use these formulas. So the first thing that I'm going to do is I'm going to solve, you can do it in any order you want if you're trying to do one of these tables. So to find hydroxide, I'm going to use this bottom one, which is 1 times 10 to the negative 14th, and I'm going to divide it by my hydroxide or my hydronium ion concentration. When I press enter, I get 2.86 times 10 to the negative 12th. To find my pH, I'm going to take my negative log of my hydronium ion concentration, which is the 3.5, and then when I do that, I get 2.46. I would like you to try to do these along with me. If you need to pause it in order to do this, make sure you do that because you do need to have these buttons understood. The pOH is going to be 14 minus my pH, which is 2.46, and I get 11.54. You can also take the negative log of whatever, and so you got that to get your pOH concentration. Solving for this, I look at my pH always. I do personally. For my, whether it's an acid, base, or neutral, it is under 7, so it would be an acid. All right, now doing the next one. I have my pH is 4.5, so I'm going to immediately I'm going to find my H plus concentration. So I'm going to put in my calculator 10 to the negative 4.5 with the exponent, and I get 3.16 times 10 to the negative 5th, and its unit is molarity. My OH concentration, I'm going to take 1 times 10 to the negative 14th, divide it by the answer I just found, and I'm going to get 3.16 times 10 to the negative 10th. My pOH, I'm going to take the 14 minus 4.5, and I get 9.5. Once again, this is an acid. In addition, if you don't like one of those formulas that I used and you found another route to do it, then use it. There's no one specific route you have to take in order to solve all of these. If I'm given my last one, my pOH is 12.4. I'm going to use this one that formula in order to get my pH. So I'm going to take 14 minus 12.4, and I get 1.6. Right away, I know that this is going to be an acid. Now, in order to solve my H plus, I'm going to use the formula of 10 to the negative pH, which is 10 to the negative 1.6. Pressing into my calculator, I get 0.025 molar. And then to do my OH minus, I'm going to use this to find the OH minus concentration. We're going to take 10 to the negative pOH, which is, when I put into my calculator and press enter, I get 3.98 times 10 to the negative 13th. Those were the most basic kind of calculations. The ones I'm going to be showing you on these next few pages are a little bit trickier, okay? So what is the pH of a 0.001001 molar solution of NaOH? Okay, the first thing you need to note about this is that NaOH, because it has that hydroxide, is a base. So this molarity that I am solving for, whatever its molarity is, which is equal to some sort of concentration, because this is a base, that molarity will be equal to my OH minus concentration. Okay, so this molarity in this case equals my OH minus concentration. So my NaOH equals my OH minus concentration because it is a base, which means that its concentration, my OH minus concentration, is 0.001 molar. Now to find my pH, I'm going to take the negative log of this concentration, press enter, and I get 4. But this is equal to my pOH, and I'm asking for pH. So what I'm going to do is take 14 minus 4, and now I get my pH, which is equal to 10. Notice I'm using these 6 formulas like all over the place from the previous slide. So make sure that you have that readily available at all times, okay? Those 6 formulas. Calculate the pH of a solution that contains 5 grams of H2SO4 in 2 liters of solution. So in order to find my pH, I need to know my H plus concentration, which is its molarity. So the first thing that I'm going to need to do is find out the molarity of H2SO4. So this is 5.00 grams. Remember, I'm going to be using this grams over molar mass equals molarity times liters formula that we learned in the making of solutions unit. So I'm going to divide it by its molar mass, which is 98.1. That equals my molarity times my liters, which is 2. Okay, so when I solve that, I'm going to be over here, my molarity equals 0.0255 molar. Okay, but that is my molarity of H2SO4. Now, the molarity of my H plus is going to be double that. Why? Because if you look at H2SO4, it is contributing 2 H's for every 1 H2SO4. So because this is the molarity of 1 H2SO4 in relationship, I would need to double it in order to get my molarity that it would give up for my H plus. So I'm going to take 0.0255 molar, multiply it by 2, and this is now my concentration, which is 0.0510 molar of my H plus. But that's not even what I asked for. I asked for pH. So now I'm going to take the negative log of that number, and then press enter, and I get 1.29 as my final answer. Okay, a solution of HCl has a pH of 3.5. Okay, so from there I can directly find my H plus, which is nice. And 18.85 milliliters of this solution is diluted to 3 liters with distilled water. What is my new pH? Okay, what we're doing is we have a solution and we are diluting it. From this pH, I can calculate my original H plus. So my first job is to find my original H plus. How am I going to do that? I'm going to take 10 to the negative 3.5, which is 10 to the negative pH, and I get 3.16 times 10 to the negative 4th molar. So that's my original molarity. So now if I look at this ending part of this problem, I now know my original molarity, and I know how much of my original molarity I have. I also know how much I am diluting it to. So now I can figure out what is my final molarity, which means from that final molarity, I can then solve for pH. See how tricky this is? All of these are trying to like trick you. These are the ones that I'm giving you in these examples are the ones that you will see on a test and on the homework. So just make sure that you're really understanding what I'm asking for and what information I give you in this problem. So now that I know my molarity, what I'm going to do is I'm going to try to figure out my new molarity after I diluted it. So I'm going to use that M1V1 formula equals M2V2, which is the same formula from that making solutions unit. And so we're going to take my molarity, which is 3.16 times 10 to the negative 4th. That was my original. I used 18.85 milliliters of that. Now that is going to equal my new molarity that I need to solve for, and I made it 3 liters. Okay, so my new molarity is equal to 1.99 times 10 to the negative 6th molar. Okay, so after the dilution, I now have a concentration that is about 2 times 10 to the negative 6 molar. But I wanted to find the pH, so all I have to do is take the negative log of this number, press enter, and I get 5.70. And because it was an acid, that is its pH. Okay, the next problem that we're going to be doing, what is the pH of a 0.005 molar solution of CaOH2? Now in this case, CaOH2 is a base, so this concentration is going to tell me my OH minus concentration. Okay, but looking at this, similar to the H2SO4, notice that for every one of these guys, I have 2 hydroxides. So when I'm telling you the molarity of the CaOH2, I am actually telling you the molarity. I will need to double it in order to figure out the molarity of my OH minus. So I've got CaOH2. That is equal to my 0.005 molar. But in that one, I have 2 hydroxides. So my OH minus concentration is going to be equal to 0.01 molar. Okay, now I'm going to take the negative log of that, and what I'm going to solve for is my pOH. So I'm going to take the negative log of my OH minus concentration and press enter, and I get my pOH, which is equal to 2. To solve for my pH, I'm going to take 14 minus my pOH, and I get my pH, which is equal to 12. All right, the next one. A solution of calcium hydroxide with a pH of 11.9 is to be prepared. What mass of calcium hydroxide would be required to make 1.5 liters of the solution? So as soon as I see that word mass, I know I'm going to do my grams over molar mass equals molarity times liters. So in order to know that I know my liters is going to be 1.5, I need to figure out what molarity I need, because molar mass will be always easy. So I need to find my molar mass. Well, how do I do that? I'm going to figure out based off, my molarity. How am I going to do that? I'm going to base it off of that pH, okay? But calcium hydroxide, once again, is a base. So what I'm going to do is when I need to figure out my amount of calcium hydroxide, I need to convert this into figure out my molarity of my hydroxides. So what you're going to do is you are going to take your negative, you're going to take 4 to find my pOH, sorry. You're going to take 14 minus 11.9, and so my pOH is equal to 2.1. So to find my OH minus concentration, I'm going to take 10 to the negative 2.1, and that equals 0.00794 molar, which equals my hydroxide ion concentration. But similar to previous problems, calcium hydroxide gives off 2. So this number that I just solved for is twice as much as that with the CaOH2 would be giving. So what I need to do with this guy is I actually need to divide it by 2. And so I end up with 0.00397 molar of CaOH2. So that's my concentration that I need to end up with. And then now I'm ready to figure out my mass, because I now know every little piece of this puzzle. So I'm going to take my grams divided by my molar mass, which is 74.1. That equals my molarity, which is 0.00397 times my liters, which is 1.5. And when we solve that, I needed 0.441 grams. Okay, the next one. A container is labeled as 750 milliliters of 0.005 molar HNO3. So from this, I know instantly that I know my H plus concentration. A chemist finds that the container has been opened and some evaporation has occurred. Now the volume is 500 milliliters. So what is the pH of the original sample? So the pH of the original was this piece of information that they gave us. In order to find pH, I need to know my H plus. Well, I'm dealing with an acid because it's HNO3, and there's only one H, so the molarity of my HNO3 is going to be the same as the molarity of my H plus. They told me my molarity of my original was 0.00058. So what I'm going to need to do is I'm going to just take the negative log of 0.00058, and that equals my pH, which is equal to 3.24. Now, what is the pH? Okay, so now what it's asking for is, hey, we started with this, so I've got my M1 and I've got my V1, and I now let it evaporate, and now I know my V2. So in order, once again, find pH, what am I going to need to do? I'm going to need to find my molarity. So what we're going to do is an M1V1 problem equals M2V2. So my original M is 0.00058. My V is 750. That is equal to my molarity, which was what we're trying to solve for, and my volume in this case is 500, okay, because both of them are milliliters. When I solve for this, I get X equals 8.7 times 10 to the negative fourth, and that equals my H plus. To now solve for my pH, take the negative log of that, and you get your pH, which is equal to 3.06. All right, and then we're going to just review over titration calculations because this is a huge part of acid bases, our titrations. So an MgOH solution of an unknown concentration is titrated with a solution of hydrochloric acid. So I know I'm going to be combining MgOH2, and I'm going to be combining with hydrochloric acid. The HCl solution is 1.25, so I'm going to put that. I know it's 1.25 molar, and 5.19 milliliters are required. So I'm going to use 5.19 milliliters to required to titrate 12.61 milliliters, okay, of the magnesium hydroxide solution. What is the molarity of this? So we're trying to solve for this. So the first thing that we're going to do is we're going to start with all the pieces that we know of as far as information. But before we even do that, you have to predict the product so you have a balanced reaction. So we're going to end up with HOH and then MgCl. Worry about charges. We've got a +1 from the H, and OH has a -1, so those cancel. Mg has a +2, Cl has a -1, so you end up with MgCl2. Balancing this out, you put 2's in front of your coefficients of the HCl and the HOH. So now starting out, you're going to start with your known volume, which is 5.19 milliliters of HCl, and you are going to start your lovely conversion. So first I'm going to go from milliliters of HCl, and I'm going to go to liters of HCl. From there, I am going to use my molarity conversion to go to moles, so it's 1.25 moles of HCl for every 1 liter of HCl. And now I'm ready to go from moles of HCl to moles of MgOH2. And using my balanced reaction, I've got a 2 and a 1. So when I solve this, I end up with 0.00324 moles of MgOH2. Okay, but it asks for the molarity. So now I need to find my liters and divide it out, because if you remember back to the triangle, we've got moles equals molarity times liters. So I know my moles and I know my liters to solve for my molarity. So now I've got my moles, which is 0.00324 moles of MgOH2. And I'm going to divide it by my liters, which moving over that decimal is 0.01261 liters of MgOH2. And that equals 0.257 molar of MgOH2. And that is your final molarity. This, once again, we've just done this in the stoichiometry unit, so this should be very familiar with you when you're trying to figure out the conversion with titrations. All right, hopefully you have a basic understanding. Once again, you're just going to need to do a lot of practice problems. I personally would work on the homework packet and then also just review these notes that I've gone over and fast forward and rewind to the ones where it's a little tricky. But these are the primary ones that you will see on tests and quizzes. Have a great evening.